Thomas Kochen, former NASA science director, commented on the launch of the James Webb Space Telescope, JWST, stating that it marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. However, he noted a shift in tone, questioning whether what began hopefully has turned into a crisis. James Webb has shocked scientists, and now the question is whether the crisis will worsen or if a new discovery from the telescope will resolve the debate in physics. Discussions about old theories and who is right or wrong could indeed be coming to a temporary end, but what exactly does this mean? Have scientists really unraveled the mystery surrounding James Webb's impossible discoveries? Or are we just being stalled with flimsy explanations? Webb was supposed to bring solutions, but instead, the $11 billion project has plunged cosmology into a major crisis. All parts of natural science associated with space are currently experiencing a shakeup of the kind we last saw in the Middle Ages with the shift from the geocentric to the heliocentric view of the world. Now, we may have to recognize that the foundations of our modern physics are also flawed and that we have not come close to understanding what our cosmos really is. But how is this possible? Today's astrophysics, or the science of the physical quantities and relationships in the cosmos, is based on the basic rules of physics which essentially go back to researchers of antiquity, the Middle Ages, and in particular to Sir Isaac Newton. Ken elaborated that we built our scientific observation of the universe on these foundations, transferring the quantities and forces that were valid and observable on Earth to the universe, producing some consistent results. But as the space we can see got bigger and bigger, our known quantities no longer fit to describe what we see. This crisis began with the problem that different methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble tension. In the summer of 2022, Webb discovered so many old and highly developed galaxies in space that doubts arose about how the age of the universe was determined. Our cosmos can hardly be 13.8 billion years old if, thanks to Webb, we see galaxies that were already well developed 200 to 100 million years after the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since and has undergone a slow process of evolution of matter, cannot be correct. We are at a crossroads. Either we are making a mistake if we think that our earthly physics can be applied to the entire universe, or we have so far only deciphered a small part of the physics that really exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics that exists in the cosmos should also be found on Earth, but perhaps we have overlooked forces and dimensions on our own planet that we are now noticing in the cosmos. Webb breaks all records. It's fantastic that this telescope can pick up extremely weak light signals. Webb's 18 honeycomb-shaped mirrors effortlessly detect light that has traveled through space and time for more than 30 billion years. A special exposure method makes these faint traces of light visible for the first time. Thanks to the new revolutionary technology, we saw the light from the most distant galaxies that formed shortly after the Big Bang for the first time in the summer of 2022. These galaxies were a sensation and at the same time a bitter disappointment. Instead of baby galaxies, Webb shows perfectly developed galaxies that appear to be several billion years old. With an age of 13.5 or 13.6 billion years, this can never be the case. Scientists sometimes say that the objects and the images are impossible or not real, but Webb can only show us the truth. Science must now admit that it has probably been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see here is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with the new truths. Some of the old traditionalists, who don't want to face the new truths, vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, it also took many years before the Church was finally willing to admit that the Earth was not the center of the universe, even though there was suddenly a wealth of evidence from astronomers all over Europe. So not much seems to have changed, and although we consider ourselves much more modern today, we have a similar scenario. Researchers who proclaim something new may no longer end up in prison like Galileo Galilei, but the quarrels between researchers and the hostility towards new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tells a different story. Perhaps your mind would also rebel against this at first, and it would take a while before you could accept the new truth. There are some who are quicker to adapt and others who take longer. Many open-minded and young scientists are enthusiastic about Webb's discoveries. Rohan Naidu, the discoverer of the Glass 1 galaxy, and Stephen Finkelstein, who discovered Mars galaxy, belong to this open-minded generation of researchers. They look at Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasize several times in interviews that we simply cannot know what will happen in astrophysics at this moment. We have to wait for further measurement results, studies, and, of course, when Webb's latest images are released. Was it Hubble's fault? Let's take a look at one of the great debates in modern cosmology concerning the Hubble constant. This is the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded upon, and Belgian astronomer Georges Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we already know from alternative methods that the movement of galaxies can also be explained differently, and these approaches also provide a coherent picture in their entirety. However, they were ignored for a long time because the old theories were considered more probable. The more we see of the universe, the more discrepancies emerge. This didn't just start with Webb. Even 20 years ago, there were regions in space where the expansion was behaving differently. It was as if these regions were sometimes faster and sometimes slower, or perhaps denser or emptier. This led to speculation that there may have been several starting points or that our universe is even permanently fed by several sources, which do not necessarily all have had a beginning at the same time or at all. Alternative ideas about the shape, nature, and age of the universe emerged. Once again, researchers continued to cling to the old theories of the Big Bang and expansion. This was possibly a mistake. We have already briefly learned about the Hubble tension. In short, it shows clear differences in distant measurements in the universe depending on which fixed points we use as measurement constants. Now scientists hope that the Webb telescope, as its mission progresses, will be able to resolve this tension by making precise measurements of the distances and redshifts of galaxies. This could correct errors in previous measurement methods and pave the way for a new advanced physics. In the end, all researchers have done their best in finding explanations and theories, and they have advanced humanity's knowledge of the cosmos. We should therefore not discuss guilt but rather look ahead and rejoice in every new discovery, even if it seems unfamiliar or even shocking at first. New theories and alternative explanations are on the rise. We are probably at the exciting beginning of a new science. New investigations of these oldest points of light could show us whether they are accretion disks or jets of supermassive black holes and what is in their vicinity. We would then have to revisit our cosmology and find out whether black holes played a much more important role in the discovery of the universe than previously thought. One theory that points to this comes from British scientist Roger Penrose, who believes that the universe is constantly recreating itself in cycles and that black holes could somehow survive such transitions as gigantic stores of information. Penrose published this theory long before Webb was launched, but although the Briton is a renowned researcher, his work was not accepted. That is now changing. Webb's mission has only just begun. We already have a second deep image with the discovery of a very old structure that is so large it also does not fit into the young universe. This evidence is growing. We still have to wait and see what new images from Webb will reveal. The telescope is not only exploring the young cosmos, but is also working around the clock to complete our knowledge of exoplanets, discover new worlds, shine a new light on our own solar system, and image the most massive and beautiful structures in the cosmos in unprecedented detail. Each of these observations in the universe is ultimately a piece of the puzzle that completes the overall picture. Even measurement data on exoplanets can broaden our focus on the overall picture and provide important clues about unknown forces, anomalies, or previously unknown phenomena. There must be something like a basic matrix, and our scientists are looking for its sizes, numbers, and structures. Thanks to Webb, a revolution has now begun that is currently still causing unrest and heated discussions, but we can rightly hope that the crisis will bring us a little closer to the truth. As the James Webb Space Telescope, JWST, continues its journey into the depths of the cosmos, it serves as a beacon of hope and discovery for astronomers worldwide. Launched with unprecedented technological capabilities, Webb promises to unravel mysteries that have perplexed scientists for decades. From the origins of galaxies to the search for habitable exoplanets, Webb's mission is poised to redefine our understanding of the universe. One of the most intriguing aspects of Webb's capabilities lies in its ability to peer deeper into space and time than any previous telescope. With its large 18-segmented mirror, Webb can capture faint light that has traveled billions of light-years across the universe. This enables astronomers to observe galaxies and cosmic phenomena that existed shortly after the Big Bang, providing crucial insights into the early evolution of our cosmos. Moreover, Webb's advanced instrumentation allows it to study the atmospheres of exoplanets in unprecedented detail. By analyzing the spectra of starlight filtered through these atmospheres, scientists can detect the presence of key molecules such as water vapor, methane, and carbon dioxide. These observations are vital for assessing the potential habitability of distant worlds and understanding the diversity of planetary systems beyond our own. Webb's ability to resolve distant galaxies and nebulae with unparalleled clarity also contributes to our knowledge of cosmic structures. By mapping the distribution of galaxies across different epochs of cosmic history, astronomers can trace the evolution of large-scale structures such as galaxy clusters and filaments. These observations shed light on how gravitational interactions shape the cosmic web and influence the formation of galaxies over billions of years. In addition to its scientific achievements, Webb represents a triumph of international collaboration and engineering prowess. Developed through a partnership between NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA), Webb embodies the collective efforts of thousands of scientists, engineers, and technicians from around the globe. Its successful deployment and initial observations mark a milestone in space exploration and pave the way for future ambitious missions. However, Webb's journey has not been without challenges and controversies. The telescope's development faced numerous technical hurdles, delays, and budget overruns, leading to skepticism and scrutiny from both the scientific community and the public. Critics questioned the feasibility and cost-effectiveness of such a complex mission, especially in light of competing priorities within the field of space science. Furthermore, Webb's observations have sparked intense debate among astronomers regarding their implications for existing cosmological models. The discovery of mature galaxies shortly after the Big Bang challenges conventional theories about the rate of cosmic evolution and the formation of structures in the early universe. Some researchers argue that these findings necessitate a re-evaluation of fundamental assumptions about cosmic timelines and the role of dark matter and dark energy in shaping cosmic evolution. Despite these controversies, Webb's discoveries have sparked a renewed sense of excitement and curiosity within the scientific community. The telescope's unprecedented views of distant galaxies and exoplanetary atmospheres have inspired new generations of researchers to explore the frontiers of astrophysics and planetary science. Webb's data promises to revolutionize our understanding of the cosmos and inspire groundbreaking discoveries for years to come. Looking ahead, the Webb telescope will continue to push the boundaries of scientific exploration as it embarks on its ambitious observing program over the coming years. Astronomers anticipate using Webb to study a wide range of celestial phenomena, from the formation of stars and planetary systems to the dynamics of black holes and the interstellar medium. Each observation will contribute to a deeper understanding of the universe's complexity and evolution. Moreover, Webb's observations hold the potential to address fundamental questions about the nature of dark matter and dark energy, which constitute the vast majority of the universe's mass and energy content. By studying the gravitational lensing effects and large-scale distribution of matter, Webb could provide valuable insights into the elusive properties of these enigmatic cosmic constituents. Beyond its scientific objectives, Webb's legacy extends to inspiring future generations of scientists, engineers, and space enthusiasts. The telescope's technological innovations and groundbreaking discoveries serve as a testament to human ingenuity and our relentless quest for knowledge. Webb's success demonstrates the transformative power of international collaboration and underscores the importance of investing in ambitious scientific endeavors that push the boundaries of human understanding. In conclusion, the James Webb Space Telescope represents a triumph of scientific ambition and technological achievement. By enabling unprecedented observations of the cosmos, Webb has the potential to revolutionize our understanding of the universe's origins, evolution, and diversity. As astronomers continue to analyze Webb's data and unravel its mysteries, we stand poised on the brink of new discoveries that will shape our understanding of the cosmos for generations to come. Webb's journey is not just a scientific endeavor but a testament to the human spirit of exploration and discovery, driving us to explore the unknown and expand the horizons of knowledge.